Okay, so this is the 2014 sample paper on expected value, and we see that a random variable x has a discrete distribution. That means that it takes a whole number. The probability that it takes any other value is negligible. So complete the distribution table below and hence calculate e of x, which is the expected value of x. The expected value of x is found by calculating the sum of all the outcomes multiplied by their probability of happening. So first of all, we have to find 15. What's the probability of 15 being selected? So in order to do that, you should know that all of these values added together should give you 1. So the sum of all the probabilities is 1. So in order to find this, subtract all the other values from 1. And that will give you 0.00 0.038. So 0.038. Now, then to calculate the expected value, it's the outcome multiplied by the probability plus the outcome multiplied by the probability. That's what this symbol means, sigma. It means the sum of. So the outcome 13 has a probability of 0.383. The outcome of 14 has a probability of 0.575, plus the outcome of 15 has a probability of 0.038 of happening, and the outcome 16 has a probability of 0.04 of happening. Sorry, I'll just fix that. That's supposed to be 0.04. .004, I should say. So multiplying all of these together and adding them gives you an expected value of 13.663. Now the second part, if x is the age in complete years on the 1st of January 2013 of a student selected at random from among all second year students in Irish schools, explain what e of x represents. Well, e of x would be the expected age or the average age. So e of x would be the average age of a student selected at random. So in other words, if you were to select students over and over and over again and at random and add up their ages and divide by the number of times you've done it, then that's the value that you should get. Now the next part is a Bernoulli Trial. If 10 students are selected at random from this population, find the probability that exactly 6 of them were 14 years old on the 1st of January 2013. Give your answer correct to 3 significant figures. So we will recognise this as a Bernoulli Trial because there's success or failure. They're either 14 or they're not 14. There's a finite number of trials. It's done 10 times. And the events are independent. That is, the odds don't change at any particular time. So, Bernoulli Trial formula, n choose r, p to the power of r, and then q to the power of n minus r. We can think of p as the probability of success, which in this case is if it's 14 years of age, then the probability that they're 14 is 0.575. So that therefore the probability of failure is anyone who is not 14, which is the sum of all the other probabilities, which is 0.425. So they're either 14 or they're not 14. N is 10 because I'm doing this 10 times and I'm looking for exactly 6 successes. So plug these numbers into the formula. 10 choose 6. P is the probability of success. You're looking for 6 successes. Q is the probability of, for want of a better word, failure. And that's to the power of 4. And if you multiply all that out together, you should get 0.2476, but it says correct to 3 significant figures. So we look at our 4th significant figure, which is 5 or more. So this is rounded up to 0.248.